This is just some examples of electron configurations that we did in class, and you're welcome to look at these to see if they help you out on any of those things.
All right, so if we want to do fluorine, which is my sample problem that I had here, it's got, how many total electrons is in fluorine? If you look on the chart, how many? 9. Okay, so it's got, make sure I'm writing, got my marker here. It's got 9 electrons. Okay, the first electron is going to say, hey, I'm cheap, right? I'm going to go down here, I'm going to go in here. Where's the second electron go? Right next to it, but opposite spin, right? And we write that, if we're doing arrows, we write them down in. And I don't know why they do it, but they usually, it's just like a one-sided arrow. That's how I've usually seen this done. Doesn't really matter. I wouldn't, it's not a big deal. Okay, so that's 2 of those 9 electrons, right? The next 2, okay, well, there's the first one. There's the second one. So now we're up to 4. And now we're going up to the 2p level. And we've still got, what do we got? 5 electrons left. So we're going to put 1 in here, 2, 3. Because remember, according to Hund's rule, we're going to fill all of those orbitals first before we double up. It's no different than, hey, there's 5 of you going to go and share a room with 3 beds, or whatever. You're going to always fill the beds first, and then you're going to double up. So if there was only 3 people, we're all going to sleep in a different bed. It's just kind of how, it's a natural thing. I mean, it just makes sense. Okay, so there's 3. There's our 4th and our 5th, so a total of 9 electrons. Now, writing this chart is a pain to do this all the time. It gets to be long, and if you don't have the chart, it gets to be really a pain. So there's a shortcut configuration, and so we're going to take that, and that's what we will do most of the time. So we're going to say, okay, so to indicate this 1s, and that there's 2 electrons, and I put a little 2, 1s2. Do not write it as 1s squared, or call it 1s squared, because it really isn't. It's just a configuration, a shortcut method. Okay, the next one is 2s2, and then 2p5. So this is my configuration for fluorine. And notice that we said it has 9 electrons. If I count all the superscripts, that should total back to 9. That's an easy way to figure out, did you do this right? I mean, do you at least have the right number of electrons? So there's my configuration for that one. All right, let's do another one. Let's do one that's a little bit harder. So let's go down and do chromium, which I think is number 24 if I read my chart right. Chromium, and that has 24 electrons. Okay, and I want to show you, this is one of those exception ones. So let's kind of take a look at what we would do. First of all, first 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are my first 10. Okay, 11, 12, 13, 14, 15, 16, 17, 18. And now, the 4s, if you look on that chart, it's a little lower than the 3D. Okay, so now I'm going to go and, what did I say I'm at? 18? Is that what I'm at? 18, 19, 20. Okay, 21, 22, 23, 24. Now, if we were to write this out right now, we would say, and understand this is not the final answer because this is one of those exception ones. So this would be 1s2, 2s2, 2p6, 3s2, 3p6. When I write my final answer, I want to get all my 1 levels together, all my 2s, all my 3s, all my 4s. So then I would write the 3D, even though that's not the order it fills, and then 4s2, which barely made it on the screen. That's how we would think it'd be done. But here's what happens. Think about it this way, okay? Here we are. We've paid for these rooms. We've got all the rooms paid for, but there's an empty bed. So if you're in that room with your friend in 4S, you could stay in the cheap room and double up in beds, or you could say, you know what, man, there's an empty bed in the 3D room, I might as well go use it. And that's what happens. So what happens is this one here leaves, and he goes over here. So there are certain exceptions. They happen when you have one, you're like one away from filling this room. That's an exception. So like a D4, when you see that you don't ever really get a D4. Or if you're at D9 and the guy down here says, you know what, if I'm going to have to double up anyway, I might as well go double up in the nice room, right? Might as well go up here and be in the better room. So that's what happens. So really now, this is what it should look like. And then when I finally write out my configuration, it should be 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d5, 4s1. Yes?
How do you know which one it takes?
It always takes it from the S1 right before it. Okay? So the reason that this can happen is because those levels are so close together in energy-wise that it isn't a big jump for it to go to that other one. That's why, to go from the P up to here, too big a difference in energy for it to make that leap. Okay? But this so close that it will do that. Now, we will worry about exceptions when they happen in the Ds. D4s, D9s. When you start to get into filling Fs, then there are even more exceptions. We will not worry about any of those. So for you guys, you don't need to know any of the exceptions in the Fs. But and this is what I just really say, remember this. When you get done, if you ever write a D4, it needs to click in your head, that is wrong. I got to steal one. Or if you ever write a D9, same thing. There are no D4s, there are no D9s. Just stop those, and steal one from the F. All right, so what I want to do, let's try using a little marker here. So I want to do magnesium. So if you look at magnesium on the periodic table and you find it, looks to me like it is number 12, right?
Number 12.
So therefore, 12 electrons. So what we want to do is figure out how these are going to fill. And remember, they're going to fill first the lowest ones. So the first one, it's going to go right here. Now the second one is going to go in that same level because it's not going to go up a floor or to a new room until the room's filled, until that level is filled. And so the second one's going right here. So that's where the first two are going. Now, you can, at some point you might have to draw these. But also at another point, we want to write them in a shortcut method. And so the shortcut method, how we are going to do this, notice that we are in the 1s. So we're going to say, hey, that's 1s. And there's 2 electrons. So we're going to use a little superscript 2. Now don't read this as 1s squared. That annoys me. Read it as 1s2. Okay? That's the first 2 electrons. The next one is going here. Where's the next one going? Just the opposite. It's going to be going that way. Remember, they're opposite spin. So that's a 2s2. So far, we've got 4 electrons in. We need 8 more. Okay, where's the next one going? It's going to go in 2p. How about the next one? Is it going to go opposite?
Oh, wait,
No, it's going to go in the next bed, right? That's Hund's rule. They're going to fill all these other ones first. So that's how it would go, even though this room's going to get full here. That's how it would go. Now we're up to 7. So there's 7. The next one's going to go down. 8, 9, 10. Okay, so I'm still 2 away. But 10 gives me, that's 2p. And how many electrons are there altogether? 6. So it's 2p6. And then I've got 2 more. So the first one here, second one down, 3s2. So this is my shortcut configuration because you know what? It's kind of a pain to draw arrows and boxes all the time. So this is the shortcut way. And so it's just the way that I would say this is here's the electron configuration for magnesium, 1s2, 2s2, 2p6, 3s2. All right, let's do one that's a little more complicated. Let's do copper. And what is that, 29?
28.
29, I think. Yeah. You guys can't read. 29.
I can't see it from here.
I know. 29. All right. So let's kind of work through this one a little bit faster. Okay. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now notice that the 3P, I'm going to go, the next one, if we go across here, notice that, I didn't draw very straight there. Notice that, come on here. Whatever. I can't draw. Notice that this is a little bit below that one. It actually is below it. I'm just drawing crooked. Okay, so the next thing that fills is the 4S. So we are at, where are we at, 18? Okay, so there's 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Now, there is an unusual thing about, these are the exceptions. There are some exception things here. Anytime that you have something that finishes with a D, so let's do scandium, SC, which is number 21. 21 electrons, therefore. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21. So the way I filled was 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. The way I write it would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2, because I want all of those 3's together. I want all of my 2's together, all my 1's, and all my 4's. Okay? So I want to rewrite them in such a way that all the levels go together. Does that make sense?
Yeah, I just didn't get why you moved.
All right, so let's say that we want to talk about, let's say we want to do magnesium. And so if we look up magnesium up there, we find out magnesium is number 12. Oh, that's kind of ugly. So, why does nothing work here? Number 12. It's got 12 electrons. And so what we're going to do is we're going to start to put them in. And remember, they're going to fill the lowest energy levels first. So here's our first one. It's going to go in here. Second one is going to go there, because that's the lowest level, 1s. Now, this gets kind of a pain to write all the arrows. It's good to show you how they go, but hopefully, after today, you know, I'd like it so that you don't even need that chart. It's faster. Because there's a shortcut way that we're going to do this. So the way that we would indicate that is that we've got 1s, so that's my sublevel that I'm in, and there's 2 electrons, and we put a little superscript like a exponent in there, 1s2. Now don't call it 1s squared, they always just call it 1s2. All right, so that's the first 2 electrons. Next 2, 1, 2. So now we're up to 4. Okay? So that would be my 2s2. Okay, now we're up to the 2p level. So this is 5, 6, 7. Notice we always fill those empty beds first. Then 8, 9, 10. All right, so that would be 2p6. And then the next one we have is that's 10 altogether. We need 2 more. So here's 11, 12, and that would be 3s2. So this is what we're talking about. This would be my electron configuration for magnesium. And that's a pretty easy one. You know, the lower level ones, those are pretty simple. All right, let's do one that's a little bit bigger. Let's say we wanted to do, what would be a good one? Let's do, all right, what's the number on gold? 79? All right. 79. All right, so if we want to do gold, so we're going to start off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Notice that now we're filling the 4s before we filled 3D, because energy-wise, 4s is actually lower. So it's a little bit below that 3D level. So in this case, they start to fill things out of order. Once we get past 20, once we get out to the 20th electron, now we start to get things a little bit out of order here. Okay? And so it's going to fill the 4s first, then it's going to go on and do the Ds. So what are we at? We're at 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. I can't draw. Okay, and now we're at 71, 72, 73, 74, 75, 76, 77, 78, 79. Now, and we've lost our picture again. There are a couple of exceptions when we do these. Come on, guy. So, I can't get this on. There we go. Okay. Anytime that you have a D sublevel, this level right here, anytime that you have a D and you have it either, you have 4 of them in there or you have 9 of them in there, what happens is it actually becomes more stable for it to steal an electron from the 4s, or from the level before it, from the S level before it. So this electron here actually will move over here. Okay? Anytime, just remember that this is kind of the key for this. Anytime that you have something that would end in a D4 or a D9, you would have an exception. And whenever you do that, we go and steal the one from the one that we just filled right before it. So, what? It doesn't. It steals it from the S. Okay? The S's and the D's are really close together, and so they'll steal it from the S sublevel. The last level that I filled right before the D was the 6S. So those two are the closest together. Okay? So if I want to now write this out as my configuration, this is kind of a big one here, but we've got 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, where are we at? 4P6, I'll go 2 lines here, 5S2, 4D10, 5p6, okay, 4f14, 6s2,
Wait, wouldn't it be 6S1?
1, you're right. Yep, I've taken the 1 away from there. Let's fix that. Okay, 6s1, and then 5d10. Okay, now, that would be great, except there's one other thing that you always need to do. And normally, I don't give you ones quite this big, because these kind of are a real pain to write them all out. Or when we do ones this big, there is a shortcut method, which we'll talk about here in just a little bit. But then what you need to do is you need to rearrange them. So we write them all out in the way they fill. That's the easiest way to do it. Just write it out the way they fill. Then go back, and you want to get all of the level 1s together. All right, so there's the level 1s, the only one. 1s2. And then all of the level 2s together. Well, those are those right here, which this stuff is kind of the same order. 2s2, 2p6. Then all of the level 3s together. Here's a 3 and that one. And so we rearrange these so that they are 3s2, 3p6, 3d10. Then we get all the 4s together. So there's a 4 there, a 4 there, a 4 there, and a 4 there. They're all separated. But we put them all back together. 4s2, 4p6, 4d10, 4f14. And then we get all of our 5s. We write those, 5s2, 5p6, what else I got? 5d10. And then my only 6 is a 6s1. So this is the final answer when we do it. Normally, most of the problems that I do, you won't rearrange more than maybe 1 or 2 things. You won't have as many of these, because I usually just don't do ones quite this big. It's kind of a pain. But you do need to rearrange them in the way that all the D's are together, or all the numbers are together. All right, so all the level 1s, all the level 2s, all the level 3s, all the level 4s, and so on. Okay? Let's talk just a little bit about the shortcut method. There is a way, because this is really, really long, there is a way that they shortcut this, and I don't know if I can really write it up here. All right, so let's do, what would be a good one? Let's pick silicon, which is number, 14? Oops, let me go with my little marker. Si, number 14 electrons. And what we're going to do is we're going to fill them following those rules. So, first electron comes along and says, hey, I want the cheapest room that you have available. And he says, okay, well, that's in the 1s room. So he goes and fills in there. Second guy says, hey, the room's already paid for. I'm going there. There's 2. Those are our first 2. Next electron comes along and says, I want the cheapest room you have available. And the owner says, well, that's the 2s room. So he goes here. 3, 4. And the next cheapest room is 2p, and following Hund's rule, we would go 5, 6, 7, right? We would fill those that way first, and then double up 8, 9, 10. And we're not there yet, so we've got to keep going. Okay, so then we go 11, 12, and we need 2 more because we need 14. So we're going to come in here, 13, 14. And now this is where we would say, hey, we're not going to double those up. It'd be easy for you to think, oh, I'm just going to write 2 of them in this one. It's not how it works. They always go in separate ones. So this is the arrow, the representation using the arrows. But now we want to do it in what we call a shorthand configuration, because this really does get to be long and annoying after a while. And so what I'm going to do is I'm going to write these sublevels and then indicate how many electrons are there with a superscript. So I'm going to say 1s2, that's to indicate these 2 electrons. So 1s tells me it's in that 1s sublevel. The little superscript 2, the exponent 2, tells me there's 2. Don't read it as 1s squared. That's not how you read this. You'd say 1s2, and then the next one is going to be 2s2, and then 2p6, because there's 6 in there, and then 3s2, and then 3p2. Does that make sense? So this is the electron configuration for silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Here's what I'm going to tell you. This stuff, after you do it a while, you realize everything fills in the same order. You get used to saying 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and it goes on and on and on. And you can just kind of rattle them off after a while if you do a bunch of these. So don't get panicky about the order, and I'll also kind of show you a way to figure out the order, because, like I said, you won't have this chart on the test. So, all right, so that's the first one. Let's try another one, and let's try one that's a little bit bigger, and let's go with molybdenum number 42. Now that's quite a few, so I'm going to kind of do this one pretty fast, but I want to show you this one because it's one of these that kind of messes us up just a little bit. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now notice that the next one I'm going to is not the next one in the 3 level. The next one is the 4S. 4S is actually, if you kind of see this, it's a little, and I can never draw straight here, but it's just a little bit below that one there. So the level is just a little bit below it, so that's the next one I fill right there. And then I'm going to fill all these guys. All right, so what have I got? I've got 20, 32. I'm at 32. I need 10 more. 33, 34, 35, 36, 37, 38, 39, 40. That isn't right, I don't think. 41, 42. I don't think that's right. Let's see. This is 10, 12, 18, 20, 30, 36, 37, 38, 39, 40. 41, 42. Yep. Okay. So there's my 42 electrons right there. Now, there's this weird thing that happens when you start to get to the D sublevel, that it actually becomes more stable if this whole level, instead of being 4/5 filled, or each bed, there's one in each one out of 4 out of 5 of them. It's actually better to steal one of these electrons from here. It steals it from the S1 that's right before it, that fills right before it, and brings it in here. And then that becomes a little more stable. So what happens is you get this kind of a configuration. We get this, let me get all this out of here. Okay, you get one in the 5S and one in each of these. Now I think of it this way. Let's say that let's think of it as people. You're out and you've rented all these rooms, right? And you got 2 people in the 5S room, which is the kind of small, shabby room, right? And then you got 4 people in the D room, and there's 5 beds. Hey, wouldn't you rather go sleep in the bed by yourself, in the nicer room? So that's what happens. It goes up there. There are exceptions to these configurations. Anytime that you have something that ends in a D4 or a D9. So if you ever write these out and you get D4 at the end, you got to fix it because it doesn't stay that way. Or if you get D9 at the end, you got to fix it because it doesn't stay that way. Okay, so just be aware of that. They'll steal one then from the S sublevel that just filled right before it. All right, so now let's write out the configuration. 1s2. 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d5. So notice I've stole one from the S, gave it to the D. All right, one other thing you got to do when you get to big ones like this. They want you to rewrite them so that all of the level 1s are together, all the level 2s are together, all the level 3s. So, that's not a problem through the first one. All the level 1s are right there. All the level 2s are right there. But if we look at level 3s, there's this one and then that D over here. And we want to write it so that it's together. So at this point on, we have to kind of rewrite. So this should be, up here it'd be 1s2. I can't do it. Let's just start over. Okay? So writing it all out, we're going to say, hey, it's 1s2, 2s2, 2p6, 3s2, 3p6, and then I'm going to put the D10 together. So we put all the level 3s together. Then all the level 4s go together. Notice there's 3 of those and they're all separated. So it's going to say 4s2, 4p6, 4d5, and then I've got my 5, my 5s1. So this is the correct final configuration for molybdenum number 42. So this one's got 2 things you got to worry about. You got that exception that happens with any D4s and D9s. Okay? It's going to happen with chromium, molybdenum, and tungsten. It's going to happen with copper, silver, and gold. Those are your exception ones. Those are those 6. Okay? And then you also need to rearrange all of these when you're done.